Okay, conditional probability. So it's defined as the probability of an event occurring given that another event has already occurred. So number one, Hillary's a coach of a junior ultimate team. Based on the team's record, it has a 60% chance of winning on a calm day and 70% chance of winning on a windy day. Tomorrow, there is a 40% chance of high winds, and there's no ties. So what's the probability that they would win? Okay, so we're going to do a little bit of a diagram situation. So the first thing I'm going to do is the wind. So there's a 40% chance of it being windy. So I'm going to go windy, 0.4. 40% chance that it's going to be windy. So what is the chance that it is not windy? What's the chance that it's not going to be windy outside? If this was 40%, then this is what? 60%. Okay. They have a 60% chance of winning on a calm day and a 70% chance of winning when it's windy. Okay, so windy, we could either win or lose the game. If it is windy, we have a 70% chance of winning. So if it is windy, we have a 70% chance of winning. Therefore, the odds of me losing on a windy day is 30. What if it's a calm day? Not windy, calm. What are the odds of me winning or losing when it's calm? So there's a 60% chance of winning on a calm day. So 60% chance I'm going to win when it's calm, which means 40% chance of losing on a calm day. Okay, so you have 4 things out of this. We're going to times. So 0.4 times 0.7 makes 0.28. 0.4 times the 0.3 makes 0.12. 0.6 times 0.6 is 0.36. And 0.6 times 0.4 is 0.24. Okay, by the way, does anybody know what all of these decimals should add up to? What should they add up to? All the things that could possibly happen should always add up to what? 100% or just the number 1. So this physically would add up to 1. Okay, what are the chances they're going to win? So this is them winning on windy, and this is them winning when it's calm. So now we're going to add those probabilities, okay? So there is a 0.64 probability, or you could say it as 64% chance. Doesn't matter however you want to express it. So you can leave it 0.64, that's good. If you want, you can express it as a percent, 64%, whatever. I'm full points either way. Okay, according to a survey, 91% of Canadians own a cell phone. Of these people, 42 have a smartphone. Determine to the nearest percent the probability that any Canadian you meet during the month in which the survey conducted would have a smartphone. Okay. So, 91% of Canadians own a cell phone, which means 9% don't own a cell phone. The people that own the cell phone, how many of those people have smartphones or not smartphones? So out of those people, 42% have smartphones, and what's left? 58? And this is just going to stop, right? Because I can't say you have a smartphone when you don't even have a cell phone, right? So that's just out. Okay, so what are we trying to figure out? What's the probability that any Canadian you meet during the month has a smartphone? So I need that. So you need to times those together. So 0.91 times 0.42. All right, number 3. We're talking about people in North Dakota with medical insurance. So 78% of North Dakotans have medical insurance. The chance of them going for a major surgery is 65 if they have insurance and 40% if they don't. So what's the first condition I'm worried about? If they have insurance or if they have no insurance. So they either have insurance or they don't have insurance. So it says here that 78% have medical insurance, so that's 78%. Therefore, 22% don't have insurance. Then the next criteria is determining if they're going to go for a surgery or not go for a surgery. So first criteria was, did they have insurance? And then after that, deciding if they're going to go for a surgery or no surgeries. The chance of a North Dakotan going for a major surgery is 65% if they have insurance. So if they have insurance, and they would have a 65% chance of going for surgery, leaving me with 35% not doing a surgery. And 40% chance of going for surgery if they don't have insurance. So 40% if they don't have insurance, which means this is 60%. So what is the probability that they will go for surgery? So I need this one and this one. So 0.78 times. So I times 0.78 and 6.5. So that's what those ones times together to. And then at the end, the total would be, I need to add those numbers now. So there's a 59.5% chance that someone will go for surgery, whether they're insured or not. Okay? So use these diagrams, that's very helpful. Okay, so then 5.6 is independent events. So dependent is events that don't rely on each other, they don't affect each other, dependent events affect each other and independent don't affect each other. So a computer manufacturer knows that in a box of 100 chips, 3 are defective. Jocelyn will draw 2 chips at random. Determine the probability that she will draw 2 defective chips after not replacing the first one. Okay, so she's going to go in, pretend that they're in a box, you're reaching your hand in. What is the probability that she is going to draw a defective chip? So how many chips are in there that are bad? 3 chips out of the 100. She doesn't replace it, so let's just pretend she puts it in her pocket, then goes back to the box. Now, what are the odds of you getting a second defective chip? So how many defective chips are in the box now? 2 out of how many total chips in the box? 99. So this probability is 6 out of 9,900 chance. Okay, and that's fine. You can leave it like that. Remember there was that one feature on your calculator that if you did something like this, you can go this button called Math Fraction. Oh, I guess it's too small. It won't do it on that one. Never mind. Sorry, didn't show you that. It's too small of a number. It doesn't even want to tell you. Okay, next. Mokhtar and Chantel are playing a game with a die and a coin. Each turn consists of rolling a regular die and tossing a coin. Points are awarded for rolling a 6 or tossing a head. Okay, so you get 1 point for either outcome. You get 1 point for either outcome. You get 3 points if you do both things, and you get 0 points if neither thing happened to you. Okay, so what are the chances of getting either outcome? So either. So I need either a 6 or a head. So the chance of me getting a 6 on a dice is 1/6. There's one of those on the dice. What do we do in math if I want to do this or that? What do I do mathematically? Add. . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . or getting ahead. Okay, so this would be, I'm just going to make this a 2 out of 12. This would be 3/12. Okay, 3 points. What is the probability that you would get both things happening? Okay, actually I have to do this differently. I think I did this wrong. Backtracking, I think I did this wrong. I think I have to think about this differently. I'm sorry. Okay. Here's what could happen to you. If you want to get either, what are the 2 ways you could do this? You could roll a 6, but then you would not get a heads. Right? That would be the one situation. I want to see if this, I don't think this will come out the same. So you're getting one and not getting the other. Or you could not get a 6, but you could roll ahead, right? Because you're supposed to get one and fail on the other. Or you could have flopped that around. So rolling a 6 and getting ahead is 1/12. Or you could have not rolled a 6 and gotten ahead. So what's the chance of me not getting a 6 on a dice? 5/6. And the chance of me getting ahead, so 5/12. So actually no, they don't work out the same. So why? So you have to take that into consideration. Sorry about that. So there's a half chance that would happen. So there's a 50% chance that could happen to you. Okay, what's the probability that you're going to get both? So you have to get a 6 and a heads. So 1 out of 6 and 1 out of 2. You have to get a 6 on the die and you have to get a head. So that's 1/12. So that's 8.33% chance of that happening. So what's the outcome that you're going to get neither? So to get neither, you have to do a not 6 on the dice. And you're going to have to roll or flip a tail. So not getting a 6 is 5/12, or 5/6, sorry. Five, 6, and getting a tail is a half. So that makes 5/12. What should all of this add up to? it should add up to 1 or 100. So that adds up to 12 over 12. So that works. Yeah. Sometimes if you need to find one, you can always do 100% minus the other events. You can use that strategy as well. Okay, 1,000 tickets are sold for a charity raffle. There's going to be 2 draws. The first draw will be the grand prize, and then the second draw will be for the consolation prize. After each draw, the winning ticket is returned, so you could win twice. Max bought 5 tickets. Determine the probability that he will win at least 1 prize. So we could do it this way. He could win and then lose. Or he could lose the first draw and win. Or he could actually win both. So everything is returned. So every time there's still going to be 1,000 tickets in, because you keep returning your tickets. So each draw has 1,000 tickets. Okay, so winning at least 1 means you could either win 1 or you could win both. Okay. So winning is, what did he buy? 5 tickets. Then losing would be 995, right? So every time you see a lose, does this make sense to you? Did you get 9975? Out of 1,000,000. Okay. You could also do this as 100% or 1 minus the opposite event. That would have been faster. So what is the opposite event of not getting at least 1 prize? Would be no prizes at all. So if you got no prizes, that means you lost on the first draw and lost on the second draw. Okay, and it will come out to the exact same answer as that. Okay, so it does say to express it to the nearest 1/10 of a percent. So as a decimal, just 1.00%, I guess. Yeah, just 1%. It's a 1% chance that you're going to get at least one prize. And that's what raffles are all about. A 1% chance that you're going to get a prize. So what if we did this where we didn't replace the first draw? What would change? Then you would have to change this to a 9.99, okay, and you would be taking down your numbers. Okay, so let's try it with the lose-lose situation. So 1,000, and if we didn't replace, this would be 999. So how many losing tickets would you have to pick from? So 995. Then it would be 994 because you didn't replace the ticket that you would have picked. That's how it would change. Okay, number 5. Tanya estimates that she has a 70% chance of passing French and a 60% chance of passing chemistry. What's the chance she's going to pass both French and chemistry? So 70% pass times a 60% chance pass means there's a 42% chance that she's going to pass both. Probability of passing French, so 70%, but failing chemistry. So what is the chance of a fail in chemistry? So if this was 60, this is 40. So that is a 28% chance. What is the chance that she's going to fail both? So a 30% chance fail and a 40% chance fail. Okay, pass exactly one class. So you have to do situations again. You could pass French and fail chem, or you could fail French and pass chem, because you get to only pass one class. So that would be your options. So you would have to do both situations and add them together. So passing French, failing chemistry, we did that one. Fail chemistry, fail French, but pass chem. Okay, so make sure you're understanding that there's different situations. So sometimes in a draw, if you could draw something, you might win-lose or lose-win if you want to try to win once or something like this. Okay, 2 more questions and then we're done. Okay, in a jar of marbles you have 10 blue, 8 red, 5 green. What's the probability that You draw a blue and then a red without placing your first marble. Okay, so how many is this all together here? 10 plus 8 plus 5. We have 23 total marbles. So my first draw out of 23, I want to draw a blue. So I have a 10 out of 23 chance of getting a blue marble. Then I took that marble, the blue one, and I put it in my pocket because I didn't replace it. So now on the second draw, I'm only going to have 22 marbles in the bag. And I'm trying to now get a red one. So 8. Okay, B. You draw a blue and then a red with replacing your first marble. So that means every time I go in, there should be 23 marbles in the bag because I replace it. So if I do a blue, there's 10, and then a red, there will be 8. Okay, so replacing or not replacing. Make sure you're reading. Okay, what are the chances you draw 2 of the same color and without replacing the first? So if I want to get the same color, there's a few options I could do, right? Situations, I could go blue, blue, or I could have done a red, red, or I could do a green, green. So we're going to have to do 3 situations. That's how I could get the same color. So you aren't replacing. So I'm going to go here, I'm going to do 23 and 22 on each of them because I don't replace my marble. So if I get a blue, the first blue was 10, but I didn't replace it. So the next time I only have a 9 to get, 9 options to get. Red, the first pick, I would have 8 choices and then 7. And then the green, do the same thing. 5 on the first pick and 4 on the second pick. Okay, the next one. You draw 4 cards consecutively out of a deck. What's the probability that you draw 4 aces without replacing after each draw? Without replacing. Okay, so on the deck, what's the total cards here? 52. So drawing an ace, I have a 4 out of 52 chance of drawing an ace. I don't replace. So the next chance is 3 out of 51. Keep going. You have 4 draws to make. Okay, that's a pretty small chance that that will happen to you. And again, how would you do this differently if I allowed you to put your ace back into the deck after each draw? What would you do then? Then you would go 4 out of 52 replaced, so you can just do that over and over. Each time you draw, you would have the same